I will talk through question 6a because I understand it's a little bit confusing. This is not how I did the question in class. So the only thing you're told is that you need to find the instantaneous rate of change. And they don't give you a point. So this is kind of an interesting situation. So let's just go with the definition that we did today. The limit as h approaches 0, f of x plus h minus f of x all over h. So what I'm going to do is first I'm going to plug x plus h into this function, which will give me, again, I'm plugging it into just this slot. So x plus h quantity squared plus 3. And then I'm going to subtract from that f of x, which is just x squared plus 3. And the whole thing is over h. Oops, and I forgot, we have the limit as h approaches 0 of that whole thing. Okay, so let's work that out. The limit as h approaches 0, I am not plugging in a number, but I'm just going to work this out. I know I'm going to have x squared plus 2xh plus h squared plus 3 minus x squared minus 3 all over h. The 3's cancel out, the x squareds cancel out. So all I have is the limit as h approaches 0 of, I'm going to factor in h out of each of those terms, which leaves me with 2x plus h all over h. Then, of course, the h's cancel out. So now I'm just looking for the limit as h approaches 0 of 2x plus h. And now, in fact, it is safe to plug in h is equal to 0. And what will happen is this term is just going to go away. That's going to be 0. So all I am left with is 2x, which is kind of interesting. So here's what we're saying. We are saying that, in fact, for any value of x, I can find the instantaneous rate of change. So if I looked at the graph of x squared plus 3, which I know is a parabola, moved up 3 places, what I would say that is that at x is equal to 0, IROC is going to be 2 times 0, which is just 0. So in other words, at this point right here, when x is 0, if I were to draw in a tangent line, it would have a slope of 0, which seems reasonable because it's horizontal. If I was going to take the place where x is equal to 1 and look for the tangent line slope, so at x is equal to 1, IROC would be 2 times 1, which is 2, which seems reasonable. At x is negative 1, IROC would be 2 times negative 1, which is negative 2, and that seems reasonable as well. So when we find the instantaneous rate of change in terms of x, basically we are getting a formula for finding the IROC at any particular x value that we would want to find.